Let's prepare on the TNPSC AE 2019 question paper. In plastic analysis, the shape factor for a circular section is what? So here the answer is 1.7. The accurate answer is 1.69. In the same question paper, we have already seen that they have asked for the shape factor for the rectangular section also. Okay, for rectangular it is 1.5 and here it is 1.7. So actually what does this shape factor means? It is just the ratio of the plastic moment to the yield moment, or you can write it as plastic modulus to the elastic modulus. Okay, so with respect to that only they will be taking the value for this, and based on that we are getting these values. Other values are for diamond it is 2, for triangular it is 2.34, and for tubular, that is tubular circular section, no, it is 1.27. Question 132. The theorem of three moments for the solution of continuous beam is formulated by Clapeyron's. Okay, so the answer itself is the Clapeyron's theorem only, we call it as the three moment of theorems. Okay, 133. To avoid the tension in a short column, the load must be where? Okay, so it is within the middle third of the cross section. So this we have studied in the columns and struts of strength of materials as core. So core of a section means where the load has to be applied, so that only tension will be there in that, only compression will be there in that column, so that no bending is occurring in that column. So that only here it's asked to avoid the tension. So it is middle third rule, we call it as like that. So here it should be within the middle third of the cross section. Okay, actually this is for a square or rectangular section. If they ask the same thing for a circular section, mean it is middle fourth rule. So it should be a d by 4 only. So here the d by 4 is, that is middle fourth is not there in the option. So we can choose this directly. 134. A propped cantilever of span L is subjected to a concentrated load at midspan. Then the MP is plastic moment capacity of the beam. Then the value of the collapse load will be what? So it is 6 MP by L. So this we have already studied in the previous TRB questions and all. So there will be this MP value, this plastic moment capacity value will be given for various different types of beams. So to study all those values are very important. So let us see now that. So here the first case is simply supported with the central load. So it is 4 MP by L will be your collapse load. And in the second case, simply supported with the load at a distance of A from the left end. So it is MP L by A into B, and simply supported with UDL means it's 8 MP by L square. And propped cantilever with the load at a distance, it is MP L plus B by A into B. So these are the propped and simply supported cases, and the next two are very important, that is propped cantilever beam with the central load W, it is 6 MP by L, and propped cantilever with UDL, it is 11.656 MP by L square, and fixed beam with center load, it is 8 MP by L square. And then fixed beam with the load at distance A, it is 2 MP L by A into B, and fixed beam with UDL throughout it, it is 16 MP by L square. 35. A 3-hinged parabolic arch of span LM and central drive YC carries a point load W at X meter horizontally from the left hinge. Okay, and then it's given us the normal thrust T at the section under the load if the horizontal thrust is such and vertical reaction is V. Okay, so it is a structure like this, which is a 3-hinged arch. So at a distance X from the left hinge, so this may be X, any distance it may be X. So here a load is applied. So the load they have given it as W like that they have mentioned. So here horizontal thrust will be coming, and here vertical reaction will be coming. So that also they have given us H and B. Now they have asked for T, that is the normal thrust. So where this normal thrust actually occurs means here the load is occurring now. So there only it splits. Okay, so if this is the vertical load, see this is the vertical load means the thrust will be acting like this. So this only we call it as the thrust. So that is the inclined member of that load. So when we want to find the inclined member, we have to resolve it into horizontal and vertical. So we can add those things. So with respect to this and keeping the angle as theta, they have written H cos theta and V sin theta. So H cos theta will be your horizontal angle, horizontal line, and V sin theta will be your vertical line, so that the summation of these both will give you the horizontal thrust. 136, the effective length of the column fixed at one end and pinned at the other end is what? So it is L by root 2. So this also we have studied already. 2L is for the beam with free end, that is the fixed beam with free end, and L is for the beam with two ends hinged or pinned, and L by 2 means it is two ends or fixed. 137, statically indeterminate structures can be solved by what? So it is using the equations of statistics and also the necessary numbers of compatibility equations. So as it is indeterminate, the equilibrium equations are not sufficient, so we need an extra equations like compatibility equations. 138, the most important source of water for public water supply is rivers only. So from the rivers only the water will be taken and the water treatment is done, and after that only it will be given for the public. 139, the carryover factor in a prismatic member whose far end is fixed is what? So it is 1 by 2 only. Okay, so if moment is applied at one end is m, means in the farther end, that is the fixed end, the moment will be m by 2 only. So this is in the case of fixed end. When the other end is pinned or hinged means the carryover will be 0 only. Okay. 140, the fixed end moment of A of the fixed beam is what? So this is the fixed beam with 2 point loads at a distance of L by 3 each. So if this is the case means the value is 2 into PL by 9. So here the load they have mentioned it as W, so they have written 2WL by 9. So this is the direct formula to be studied, which is derived from the 3 moments of theorem. Thank you and keep watching.